So for the most part, this should seem pretty familiar. If we're calculating the S of reaction from the S values, it's the same process as how you get the H of reaction from the H values. So again, the standard state, it's all in the chart. We're using the far right column here, is 1 atm and 25 degrees Celsius. The units, you can see at the top, look, if you look all the way over, it's joules. And that's different because H and G are kilojoules. So joules per, and then this is a Kelvin and a mole in it. So the temperature right there is important part of entropy. Because the higher the temperature of something, the more disorder it's going to be. And again, when you read the chart, it's alphabetical, but it's alphabetical by name. When is SF 0? Well, let's take a look, make sure you're looking at the far right column, and I'm just going to scroll upwards. I'm going to keep scrolling. Are you seeing any cases where S is 0? Nope. S is not ever 0 because there's always assumed to be some kind of entropy associated with that value. Okay, so let's just do our same calculating. We just got to make sure we're grabbing that third column. I'm already in the C, so if you look at my arrow right here, I'm going to the third layer of that C. And I'm going to do my little trick first where I put my coefficients in. So this is 1 times, 3 times, 2 times, and 3 times. And so now I'm going to look in this row, all on the right. You'll notice that's my CO. So that value is 197.7. And then I got to find CO2. It's just below it. And scroll that one over. So that's 213.8. And I'm going to find my iron. I'm going to scroll fast to get to the I's. Iron. And then I need Fe as a solid. And over there, his value is 27.3. And then the Fe3O2, this value is 87.40. And I'm not saying that entropies are always positive, but most of the time, if you look at this, they really are positive most of the time. So just be careful when you're writing them down that, I mean, most of the time, just double check if you write down a negative entropy. And remember, it's a summation, it's product minus reactants. In all of Gen Chem, you're going to be finding yourself saying products minus reactants or products over divided by reactants. Those are products get preference, I guess you can say. So if we're solving for H of reaction, notice I'm writing it under the arrow again. I'm going to throw that out of the way. I've got these two guys, copy, paste, and they're added together so that, and you don't need the parentheses, I'm just putting it to distinguish. Those are my products. And then I'm going to grab the right-hand side. And these are my, make it a little smaller. These are my reactants. Remember, I'm adding them. Notice that my negative is going to apply to him and him. So I'm going to go ahead on my next level of this and distribute. So I'm going to make this right here negative, and this right here is going to become negative. So I'm going to put all of those numbers in the calculator. 2 times 27.3 plus 3 times 213.8 minus, and 1 is 187.40 minus 3 times 197.7. So if I look that all through again, double check your calculator right there, all those numbers before you push the enter. Make sure you don't drop something. And so I get this value is 15.5 joules per mole Kelvin. And if we're talking about kind of like scales of reactions and everything, notice we have like one solid that's kind of big, making 2 solids. Solids don't have a lot of influence on disorder. And we've got like 3 gases going to 3 gases. So notice we don't have a huge enthalpy value, which is fine. But you know, that might be expected if you're not doing a huge change on your phases.